This is another video in the KAS IDE series going over different features of our programming environment. I'm going to show you how to set up Modbus configuration for third-party devices, specifically using the Fieldbus editor to pick which variables you want to share, including Boolean, integer-based, floating point, and string-based variables, and give them Modbus addresses to share with an external Modbus master. I am starting with a new template program, and the first step, if I want to do a manual Modbus setup, instead of using the built-in setup using the checkboxes in the dictionary, if I'm using Kollmorgen's own KVB software, I will go to the Project Explorer, right-click the Controller section, and go to the Properties window. Here, there is a Modbus configuration section, and I can change the radio button from the default KVB panel to other Modbus devices. You also may want to put a faster cycle time. The fastest we support is 20 milliseconds in order to more quickly respond to the Modbus master you are using. Once you change to other Modbus device, you will have to also select, yes, I do want to use the Fieldbus editor to set up the Modbus configuration. Now, under the Project Explorer, if I open up the Fieldbus section, there will be a new option when I click the top button, Insert Network. Before, Modbus was not available and only our Ethernet IP and Profinet options, but since I changed that option through the controller properties, I can now choose Modbus Slave. The next step will be click this Insert Master Port button. While the Modbus Slave section is highlighted, you can keep the default slave number 1 and press OK. And there is nothing else you have to set up here. We are the slave device, so there is not very many parameters you have to set up besides picking which variables you want to be able to share and at what addresses those variables will be at. The next step is to click the next button down, Insert Slave Data Block, while you have your Modbus section selected in the Fieldbus editor. It'll bring up this pop-up screen, and you don't have to fill in the description, but you do have to pick one of the 4 options for which object you want to add. Now, input bits and input registers are read-only sections. In this case, I'm only going to add coil bits and holding registers, which are read-write variables. Most people only add the rewrite sections because in their master, if they only read them, then they sort of become read-only, but it's much easier to work with only 2 sections instead of 4. Also, coil bits is for read-or-write Boolean variables, and holding registers is a section where you put all other data types, including integer, floating point, and string-based variables. You can set these other sections, the base address or number of items, but I'm just going to go with the defaults and edit those later on. You can also optionally have variables pre-declared by this editor using a base prefix, and it'll just increment the number after it. I find it easier to use variables I've already declared in my dictionary from programming my PLC code and not going with generic variable names, so I'm not going to click the Declare Variable section. So here I'm going to just add a coil bit section, and this is for read-write Boolean variables. I'm also going to go right ahead and re-click the Insert Slave Data Block and add the holding registers section right away as well. Now that I have my coil bits and holding registers sections added to the Fieldbus editor, I have to add variables to them. First I'm going to start with coil bits, or the Boolean variables section, which are usually a little more straightforward. You can click this now available button, Insert Variable, to add variables one by one, but I find it easier to just drag and drop from our dictionary onto the Fieldbus editor. So if I go to my dictionary, I already have a global variables section open. I can pick some Boolean variables and either drop them right to coil bits, and they will pre-fill in, or even easier, when I have coil bit section highlighted, I can drag down to the section below, drag my ready variable, direction, e-stop, reset. So I just quickly added 4 Boolean variables. Now if I click the plus arrow next to the coil bit section, all of them automatically got added. You can edit each individual one by double clicking on them, but once again I find it easier to just click on the overall coil bit section, and then below from the sort of spreadsheet-like view you can double click and edit any parameter related to the variables that have already been added. The offset is what will determine the address for the coil bit variables. You can one by one manually set each address, but also another shortcut would be to right click the coil bit section and choose the renumber addresses option, and this will automatically just give them addresses in increment starting from 0 onward. So now my variables start at address 0, 1, 2, 3. Also note that we do start at 0. Some Modbus masters may start at 1, so ready variable, even though it's set up as 0 here, it may be 1 through your Modbus master. Direction, even though it's set up 1 here, it might be 2, and so on. You can do the same thing with holding registers. If I have that highlighted, then the spreadsheet view below will be for all my other variable types. So coil bits is only Boolean, but holding registers, all of my integer-based, real, long real, or floating point variables, as well as string variables, I can just drag down. So I'm going to grab some real and long real variables, also a double integer, so an integer-based variable, and a string variable. Now when doing these, once again I find it easier to edit them just down here while the holding registers section is highlighted, and not individually by clicking on each variable separately and from this upper view, but it is equivalent. The same parameters are available. There is a little bit more to set up with the holding registers. Coil bits are just Boolean, or a bit for each variable, but we have a wide different sizes associated with all these different variable types that you can put in the holding registers. So all of our real, long real, and dint variables are 32 bits or over. Now over Modbus, a holding register, each address is tied to only 16 bits. So if you want to share a 32-bit variable, you would have to give it 2 Modbus addresses, so it takes up 2 memory slots. To do that, you also have to go in and change the storage from default, or 116 bit register, to 2 of them, or double. So I'm going to change these first 3, which were real, long real, and double integer variables, to, instead of default, but double word, so that they take up 2 memory slots, or 32 bits. Note you can also have 2 options when doing the double word: high to low, low to high. This will just determine, of the 2 memory slots, which part of each variable is sent first over Modbus, the most significant digits or the least significant. Once again, different Modbus masters may be expecting it a different way, but we do give you the ability to choose either one. In my experience, the high to low is a more popular method, so that's what I'm choosing here. And also, this is a string-based variable, so you have a number of different options when you're doing a string based on the maximum number of characters that you can tie to it. The more characters, the more addresses that are tied up, so you probably do want to choose the lowest level or lowest number of characters that can possibly be in that variable, just so that you're sharing less data over Modbus and your speed of sharing variables will go quicker. So now that I have picked which storage each variable can take up, I can once again right click the holding registers section on top and choose the renumber addresses option, so that it will automatically give variables or Modbus addresses to each variable that I have selected. And also note, because some of these are double words, it doesn't just go 0, 1, 2, 3, 4. Since all these variables will take up multiple memory slots, it starts at 0, then goes 2, 4, and 6. And on your Modbus master, remember they may be offset 1. Velocity override % variable might be 1 instead of 0. then octopause 1 would be 3 instead of 2, and so on. And now, if I just downloaded or compiled, downloaded, and ran my project, it would now be open to receiving requests from a Modbus master to read or write any of these variables. Also, a good note to know is that our simulator also supports Modbus communication, so you don't have to have your actual PDMM or PCMM controller to verify that all your Modbus addresses are working. You can just download this project to the simulator and check there that all the addresses are correct and working. Thank you, and this has been another video in our KAS IDE series showing different features of our programming software.